Hello guys, today we're gonna create a consumable system and some sort of inventory. It will be quite intense tutorial, so please take a seat and keep your attention. I'll show you everything very slowly and explain everything too. So let's start. But first of all, let's take a quick look at interaction component. I need to show you this part, so it will handle the situations when we have big amounts of consumables or interactable items standing near each other and correct behavior between switching between them. So as you can see, we have the same system from the earlier tutorial when we are line tracing from our camera to our interactable object, and there are some changes. For instance, I have created last interactable variable. The type is actor, and when we are actually trying to interact with an object, first of all we need to check whether it's valid. If it's valid, then we check whether we're interacting with the same object. If it's true, we actually need to interact with our object. If it's false, it means that we are interacting with the other object. So we need to stop our interaction and switch to another. And whether we have no interactable at all, we need to set the hit actor to be our reference for our last interactable, and then start interact too. As you can see, I have do once nodes. So basically our messages to interaction interface will be sent only once, and some sorts of custom events that actually will reset our interaction. So take a look where they are located. We have reset null. It means that our reference is not valid. Reset valid new is for our valid, but when the condition is false, and reset valid previous for the situation when we have our last interactable the same as our current hit actor. And after each message, I have these calls of the functions. So reset valid new, reset valid previous, this part of logic, and both of these events are actually calling reset null. So now let's go back to our consumable. So actually, consumable object is the child which inherits from our interactable base class. So we actually need to select interactable base, then press right mouse button and choose create child blueprint class. Or you can press right mouse button, select blueprint class, and in all classes search for interactable base class. This will create the child which inherits from this class. Next, as you can see, it's called consumable base because all the logic for interaction with consumable items will be included here. Also, I have the consumables folder and 3 types of consumables. In case it's food consumable, water consumable, and cigarette consumable. All the items that you saw in the demo. They all handle their own logic, and they are actually the child of the children of our consumable base class. So every time you need to create a new consumable, you just need to select consumable base and create child blueprint class. Next, I'll show you all assets or items you need to create before we start developing our logic. As you can see, from the content browser, I have some more folders, structures, and DB. To create a structure, you need to press right mouse button, then select Blueprints category and choose Structure. It will actually define the structure or look of our consumable. Here you can add any kind of variables you want. In my case, I only need the following: icon, name can be changed, model, quantity, and position. And types of our variables. For icon, it's texture 2D to display it on our HUD. Model is static mesh, so it's the visual representation of a consumable object in the world. Quantity goes for max capacity, so it's the number that we can't go above. And the position. Position is for the proper index in our pie menu, so you can actually switch between where you need to store your consumable very quickly. And as you can see, I have all positions clear, so it's up to you whether you need some default states for all your consumables. Actually, structure is an element for creating data table, and data table is some sort of database that you can actually create a big amount of different positions with their own attributes. So to create database or data table, you actually need to press right mouse button, then go to miscellaneous and select data table. Then you need to pick the structure as a reference for our database. It's fconsumable. And as you can see, right now I have 3 positions. The raw name goes as a string index for our database. And here I define the attributes I need for each of my consumable. So for the icon for food, I go with this kind of texture, this kind of model. Actually, it has the capacity 3 and the first position in our pie menu. To add a new row, actually a new position, you just need to press on cross with the add name, then rename row name by selecting F2, and then you just need to set your attributes. Next, I have one more enumeration. It's called interactable type. Actually, because our consumable is the child of our interactable base class, when we are trying to interact with the object, we need two different behaviors for actually interacting with the object. For interactable, I'll use the hold event, and for consumable, I just use press event. So there is also another behavior of how to display the widget. So right here, right now, I have two types of enumeration strings. It's interactable and consumable. And we need to define these states both in our interactable and consumable classes. So when we start interacting with the object, the feedback will be the proper one, and all children that are actually inherited from the interactable class by default will have the interactable state. All children that inherit from consumable base class by default will inherit consumable state. So to do this, let's actually go to our consumable base class. Sorry, not consumable. First one is interactable base class. And as you can see, I have the variable which is called interactable type. And type of our variable is our enumeration, interactable type. Then go to class defaults, and in our interactable base class, select interactable as the default state. Next, as you can see, in the flow of event can interact, I have this type of logic. The reference for our interaction widget, and actually our widget should also have this type of interactable type variable. So let's open our hot interaction widget and take a look at the event pre-construct flow. As you can see, I have created interactable type variable 2, the same that we have in interactable base class, and when we start interacting with the object, our widget will show, and on the pre-construct we need to switch between our states and show the proper behavior. As you can see, I have the key type, actually text element that I called key, that show us which key to press or to hold, and another text element that we will change according to the proper states of our interactable type. So, if we are interacting with the interactable one, we need to set text for our key action, this element, to hold. And if we are interacting with the consumable, I'll actually change it to pick, and because I don't need the radial progress bar fill, I set its fill percentage ratio to actually 100. So when I start interacting with the consumable element, I have the different look of my radial progress bar. You can go with any type of logic you want, but this is pretty much simple, and in my case, I like how it works. Also, let's go to update progress bar function, and here you can see that I have the same type of logic. For consumable it's actually clear, but for interactable we need to just set our previous behavior that we had from the earlier tutorial. So when we are interacting with the object, we need to start filling our percentage rate, and if we stop interacting or our interaction time is less or equals 0, we actually need to change from the interaction time element to our key type text. And that's all for our interaction. When we are done with our interactable or interaction HUD widget, we need to add this kind of logic. So when we start interacting with the object, it will tell our widget from the interactable type element it has to which interactable type to switch. And we need it only when the events can interact. Because we are actually doing this in interactable base, our consumable base class will also inherit this type of logic. So, beside this and these elements, there is no actually difference or changes in our interactable base class from the earlier tutorial. Now, let's open our consumable base class and do basic setup. Right now, actually don't look at this type of logic. I'll explain it later. We need to actually select class defaults, and for our consumable base, select interactable type as consumable one and interaction type from 1 second to 0.02. So basically it's pretty much the same time when person presses the key. So it will interact immediately. Next, let's go to the project settings, and in my case I have two different actually keys. Actually, it's 3 different keys for interaction with the object. If we are interacting with an object, we actually press E key or hold E key. Then to open our inventory, I use the R key. Then I select by moving my mouse what kind of consumable I need to select. And when my consumable is selected, I use F key to consume it. This behavior I like because it pretty much reminds me of Dark Souls and Bloodborne series games, when you actually need to select from the inventory the proper element and then press another key to use it. It's not pretty much similar, but this behavior is what I have gone with, and this works for me pretty much well. So if it will be the proper request, I actually can do the tutorial how to make the select or multiple choices for different actions when we use only one key. So take a look. Use consumable is the name of action mapping, and we will use it in our player character. So let's go next. Now let's open interaction system interface, and I'll show you what kinds of functions we need to add to our consumable system will work in proper way. So we need to create add to inventory function. Make sure to take a look at the inputs. The name is consumable and type of variable is our consumable base. So when we need to add some element, we need to provide the reference for an object we need to store. Then remove from inventory. So the setup is the same. When this event is called, we need to provide the element we need to remove from our inventory. Next, consume. Setup is pretty much the same. So when we need to consume our consumable, we need to provide also the reference to our element to be consumed. Next, update pie menu. When we pick an object and we need to select it in our pie menu, we need to actually provide our consumable reference, so pie menu will know what data to extract and use in its child widget. Then create consumable widget. It's actually an element in our HUD that displays the active consumable. Next, destroy consumable widget is actually the events when our player character dies. We need to remove this element from our HUD. Then set active consumable. So when we select the proper element in our pie menu, our consumable widget on our head, our player character and our inventory component will know which consumable is actually active or last consumable. Take a look at the inputs all the time. Next, update consumable widget. So when we actually use the last element we have, we need to clear the display of our consumable widget on our HUD. Or if we actually don't need any active consumable selected, we can select the empty space in our pie menu, and our consumable widget on our HUD should also be cleared. And that's all for our interaction system interface. Now, let's continue. So, let's open our consumable base class. And first of all, let's take a look at our variables. I have acid data. Actually, type is data table raw handle. And as the default value, I set db consumables, our data table we created earlier, and by default their name is none. In our children, we will define the proper raw. So, water, food, cigarette, whatever we create. Next, let's take a look at our construction script. Here, also make sure that you have node called parent construction script. Also, this is similar for all our child event begin play and co-function parent begin play. To create this one, you actually need to select just begin play, then select add call to parent function. So, in the construction script, we have our asset data, then I'll use break data table raw handle, just like this, and the node called get data table raw. So when our data table is found and we have the proper raw name, it's actually how we define our assets, our consumable assets. I have another variable, it's called consumable structure. Type is fConsumable. So we have the local version of our consumable structure here. Then, as you can see, our consumable has static mesh component by default, but there is no actually model, 3D model here. We need to get our model from the database and set it to our static mesh on the construct. Also, I have mesh scale float variable. The default value is 1, so some assets are actually small, and to quickly change its size, like this, we need to use set world scale 3D and provide the same float value on all our dimensions. So this kind of logic will trigger when we put our consumable object to our scene. Also, I have max quantity and current quantity. So, max quantity is actually the integer that comes from our data table. As you can see, on the event begin play, when our game, or actually when we pick our consumable, this logic will fires, and we need to get the maximum quantity from our data table to set this quantity to our consumable. Next, as you can see, we have event main body that actually call from our interactable base. Just search for event main body. As you remember, event main body one moment. Yes, is here, and it's actually clear, so our child can use its own logic. Now, let's go to our inventory component. As you can see, in common folder, I have another folder. They're called inventory. Here I created a scene component. It's our inventory component, actually, that will handle the add and remove elements from it. So let's open it. And as you can see from our consumable base class, when the event main body fires, we actually are trying to get current consumable. It's a function that we need to implement in our inventory component. So take a look at our inventory component. First of all, let's talk about our variables. Last consumable, variable type is consumable base. Active consumable, the same type. Next, array, it's called consumable object list. It's same type, but as you can see, we need to select from single variable to the array of variables. And consumable class list. Actually, it's consumable base object, but as a reference we use class, not an object, and type is array. So I'll need to explain you the logic how our consumable system will actually work. I'll do it by displaying you, by illustrating it in the paint. So the idea behind consumable system is pretty simple. As you can see, we have 3 instances of the blue consumable, 2 instances of red consumable, and 1 instance of green consumable. And we actually need to communicate with any of these instances only once. Then we actually, after interaction is completed, attach this consumable to player character, disable its collision and visibility. And we only need 1 instance to have in the world, so we can actually trigger the logic through it. So our consumable will do what it's intended to do. All other instances, as you can see, when we are interacting with them, are actually just multiplying the integer that actually goes for the capacity. Each type of our consumable has its own capacity. And after interaction is done, this, actually all other instances of the same class, will actually be deleted. We don't need them, we only need to increment the amount we have in our consumable. Because it's very bad practice to actually store all these objects itself. You don't need it. It's extra work and it costs performance. So when we actually use our consumable, our integer of capacity will be decreasing, and when our consumable has capacity of 0, we actually will clear our array of our consumables, but will not destroy actually our consumable that we have in us. So I hope you understand the idea, and when I show you the graph with the logic, I think you will understand it more clearly. So in our inventory component, let's add event called add to inventory that we created in our interaction system interface. Then produce the consumable that we have from our interface as a reference to our last consumable variable here. And it's the debug print that fires item aids string to our screen. Here you can implement the logic. For instance, you have a custom widget that will actually show what type of consumable has been added. Next, we have a condition. We need to check whether our last consumable class is or contains in our consumable class list array. So whether it's true, we actually need to get current consumable. And whether it's false, we actually need to add the first element to our array of classes and add last consumable object to the array of consumable object list. So when we interact another type, actually the same type of the object second time, the class will actually be in our array, so we will need to actually set our consumable as a current one. Now let's take a look at the function that calls getCurrentConsumable. As you can see, here I have consumable that we're actually trying to get its class. If its class is in our consumable class list, then we get the index of this element and find the consumable object in our consumable object list. So when it's actually found, we produce it as a reference of our current consumable. Next, take a look that this function has input and output with the same type of variable, it's consumable base. Next, from last consumable, we can get current quantity. We need get current consumable function, actually define what consumable we have added to our inventory the last moment, whether it was our cigarette or our water or our food consumable. So when we have the proper consumable, we actually know which consumable we need to increment its current quantity. So as you can see, for instance, we have interacted with the cigarette one. Then we have interacted with the cigarette consumable second time. And it goes this logic, it gets the last consumable when it's found and start incrementing the amount. And when we interact for the third time, but not the cigarette consumable, but water consumable, actually it will start incrementing the water consumable. Now let's go back to consumable base class and continue here. So as you can see, right here in consumable base class, when event main body fires, we need to get our current consumable. To get it, we actually are corresponding to our player character and trying to receive the inventory component. When it's received, we can actually fire this function in our inventory component. But we don't have inventory component assigned to our player character at the moment. So for this, we need to go to player character and on the left side of your blueprint, add component inventory. That's it. Now go back to consumable base and this type of logic will work. Now we use isValid node whether to check if current consumable is actually the first one. If consumable is not valid, it means that it's the first one, then we set collision to no collision of our actor. Then for our widget, we set its visibility to false. Then we attach our consumable object to our character, and then we make it hidden. Next, we need to send a message, so this consumable will be added to our inventory. Just like this. That's the flow when we first interact with the very first instance of the proper consumable class. Next, if we are interacting with the same object class, we need to check whether its current quantity equals its max quantity. If they are equal, here I have the debug print that says full stack, so we won't be increasing it higher or above our max quantity. Here you can have the custom logic you want. This tutorial is all about how it works. This flow can be customized by you. And whether our current quantity is less than our max quantity, we actually need to add this consumable to our inventory. After this, we need to set lifespan to a small value. So this actor, after it is added to inventory, will be deleted. And that's all logic for event main body in our consumable base. Then we will return here sometime later. Now let's go to inventory component again. As you can see, here we're trying to send a message to update our py menu. So our py menu will know what type of consumable and the quantity of it we actually added to our inventory. So as you can see, it's the interface message to player controller. So let's go to our player controller. Here you can see I have implemented the update py menu event that we created earlier in our interaction system interface. And the first we need to check whether our py menu is valid. So when it's valid, we can trigger the custom function that we will create in our py menu. So first of all, let's go to our py menu, and as you can see, it changed a bit from the last time we saw it. And let's take a look at the reconstruct flow. Here we have this type of logic new. The first one is the function that will spawn the children or child widgets in our py menu to represent the consumable. And let's take a look at our content browser. We have add py menu slot. It's the child widget for our py menu. Basically, it's just an image element and a text element. The text element was added for the debug purposes, but you can use it in different way. And it has no logic at all. So just the visual representation of the consumable on our py menu. Next, let's take a look at variables. The new variables are child array list, it's add py menu slot, this type of widget, but the array. Next, consumable object list, it's consumable base class, also array. Then desired consumable position, integer and array. Actually, we needed to define the order or the position of the widget on our py menu, so it can be customizable, so you can change it very quickly. Also, active consumable, it's actually our selected or active consumable. When we select the proper sector, then close our pie menu. The element that was in this sector will be the active one. Also, I forgot about child offset radius. It's integer. This one needed to set the proper space between our child widgets on our pie menu. Make sure that active consumable is consumable base type. Now let's open spawn child widgets function and take a look. Also make sure that you have the local variable called child array and the type is pie menu slot. This type of widget. Now to spawn our widgets in pie menu so they are ordered in the radial way, we need the following logic. But first of all, let's take a look at the inputs and outputs of this function. Quantity, actually it's how much child we need to spawn. Radius, it's the offset between each element, and as for output, it's hard pie menu slot array. Now, the logic is pretty much simple. We start with the index of 1 and the quantity we provide is actually our sector count. Then this is just the sector size, but here it's for the representation purposes. We divide 360 by our quantity to get sector size. Then we multiply the index from 1 to our quantity. Right now it's 6. So we have the bounds for each sector. Then we need to multiply it to -1. So the representation of our widget on the vertical dimension will be flipped. So the order will start from the up from 12 o'clock and go on the left as it goes with our radial progress bar. Radial pie menu. Next we need to use get forward vector and make rotator on the Z axis, so the alignment will be on the vertical dimension. Next we need to multiply it by our radius, so we will have the offset for each element, and we need to add the center of our widget, so it will be aligned to the center of our screen. We also need to get viewport scale, and we need to divide 1 by this scale, so for different resolutions, or not different resolutions, but different viewport size, the position of our widget will be the same. Also, to have the alignment in the center, we need to get viewport size and divide it by 2. Then we have create pie menu slot widget node, pie menu slot this widget. Then we need to add it to viewport. That order is 100. It's up to you to decide with which value to go. Next, we need to set position in viewport to the results of this computation. Make sure to uncheck remove DPI scale attribute, then use set alignment in viewport so it is centered, and add unique, add our hard by menu slots to the local array. When this loop is done on complete, we need to actually return the array of our by menu slots, so we know exactly how much these elements we have. Now let's go back to our main graph and see that every time we open our pie menu, we need to spawn our child widgets, and every time we actually close our pie menu, we need to remove our child widgets. Also make sure to set child array list from the result of spawn child widgets function, so we can use it as a local copy later. Now, as you remember from the inventory component, we have update by menu function, so let's open it. And take a look. Our player controller is triggering update by menu data function. And we need to set the local variable that is consumable base as our last consumable here and check whether it's valid. If it's valid, we actually are adding it to our consumable object list. So, if it's not valid, we need to remove actually our consumable from our pie menu. So, when we have no consumables at all of proper class, when we open our pie menu, it won't show. For this, we use remove and we use active consumable because the flow is pretty simple. When we select the proper sector in our pie menu, the consumable located in that sector will be our last consumable or our active consumable. So we can use only one consumable at a time, and all the time we use our consumable, it's actually our active consumable. So when the reference is not valid, it means that we need to remove something. Because we don't have the last consumable reference now, but we have our active consumable reference. So it's actually the same element, and this link is, or this reference is actually valid, so we remove it from our array. Then we need to remove actually the position where this element was located, so elements on our pie menu won't change its order. Because if we don't use this type of logic, when we have no consumable of proper class, we delete it from our pie menu and all widgets will shift their positions. So take a closer look. Now, let's go back to our pie menu and continue here. After this, we will continue with our inventory component. Next, let's go to update by menu slot function. This function reorders and sets the proper position of consumable in our by menu. So we are iterating through consumable object list. It's the array of consumable base objects. Then for each element we actually get consumable structure, break it, and select position. Then we add the position to the array desired consumable position. So each element in this array has the number that we will assign for our widgets and consumable to be located in our pie menu. On the completion, we are now iterating through desired consumable position, and we can use the array index here to find the proper element in consumable object list, and we use array element as the index in child array list array, so we can get the proper widget. And as you can see, if the index valid in our consumable object list, if it's true, then we get the icon element from our pie menu slot here and set the proper texture here. So take a closer look. Also make sure to set match size. As you can notice, here we are iterating, but with a little bit trick operation. As our array element in position starts with 1, but actually array starts with the index of 0, we need to subtract the array element value by 1 to get the proper element in child array list. Child array list is actually the array of hard pie menu slots, this element. Now let's go back to our main graph and event preconstruct flow. Actually, I explain everything here. There is no changes. As for this part, it's from the previous episode. And let's see the event destruct. This event fires when we close our pie menu. When we close our pie menu, we need to get the last sector and set the element that was located in this sector as the active one or the last one. For this, we are iterating through child array list. First of all, we need to remove all our child widgets when our pie menu is closed. So whether they are valid, we are removing them. On complete, we actually need to clear our array. Next, we have the last function here. It's called select proper consumable. So, as you can see here, we are iterating through the desired consumable position, and next, this kind of logic is just the operation that sets our current sector. Current sector angle we divide by sector size, and this one will result at the sector we are actually pointing at with our mouse. So where the array element it starts from 1 and our sector also starts with 1. So where the array element equals our current position or our current sector, and we have in our consumable object list the proper index. So for instance, we have 0 index here and 0 index here, and if these indexes have this condition true, then we will return the consumable which we get from consumable object list. It's consumable base array with the array index coming from here. And on the complete, we need to return the null reference to our consumable. It means that if we have this condition works, we actually can assign the proper consumable in our pie menu. But if we want to clear our pie menu, or actually the representation of our consumable in our HUD, so there is no actually selected consumables, we just need to complete our loop. This logic won't trigger and we'll have our consumable free. So take a closer look. Now let's go back to main graph. Also, I forgot, this function, as you can see, has an output. It's consumable base class, and on the main graph here we need to provide the result of select proper consumable function as our active consumable reference. Next, as you can see, we have two interface messages: set active consumable in our player character and update consumable widget in our player controller. Now let's first of all go to our player character, then to our player controller. So now we are in our player character class, and here you can see that I have the implementation of set active consumable event. It came from interaction system interface. This event we are actually trying to trigger from our pie menu here, and I have active consumable variable that's for local use. Then I also send the same kind of event but to the inventory. So inventory will also know that we have the proper active consumable. So here in the inventory component you can see I have the same implementation. So when our pie menu will send the message that we have the actual active consumable to our player character, our player character will also send the message to our inventory. Now, the input action use consumable that we defined earlier, we need to actually see whether our active consumable is valid. If it's valid, we can use the consum and provide our active consumable as a reference to the consumable and as the object reference who is actually listening for this event. If you open consumable base class, here you can see I have the implementation of consume event. When this event fires, it also fire another event or sends a message to fire an event that we need to remove the consumable from our inventory. So when we consume something, we need to remove when it's done. And whether our active consumable is not valid, we don't need to send any messages. Also, here on the event begin play, you can see I have the messages to play controller to create consumable widget. It's the element, I'll show you here, that shows the current active consumable and its amount. We need to create it here in the HUD folder. It's this one, and if you open it, we can see that I have the horizontal box which actually stores the image and the text element. If you go to the graph, on the event graph or our main graph, you can see that I use set visibility to hidden, because when we launch our game, we actually don't have any consumables in our inventory, so we need to hide our slot. But we also have the function that is called update consumable data, and whether we have our consumable here, whether it's valid, we need to set visibility so our slot will be visible. Then, as you can see, we have our consumable local variable here, and as you can see, when we receive this or these functions triggered, we can use the reference to set our local reference, and then from our local reference we can actually extract the structure and use icon and the current quantity as elements needed to a proper look of our consumable in our HUD. I use append node here just to have the X as the multiplier sign. Capacity is text element, icon is image element. Also make sure that match size is switched off, so you can define the size of this image from your graph. From the designer. Let's move back to our player character. So, on the event begin play, we have created our slot, and on the event destroyed, we need to actually destroy it, so it will be cleared. And this is all for the player character. Now let's take a closer look to actually our consumable base, inventory component, and player controller. First of all, let's go to player controller. As you can see here, we have event update consumable widget, which is also triggered from PyMenu slot. From PyMenu here, and actually this event update consumable widget triggers update consumable data function in the widget that I just showed you. This one. And that's this function. So take a closer look. You can see that we don't use isValid for our consumable in update by menu and update consumable widget because we actually will send null references in case we need to destroy or show to hide some elements on our HUD. Now let's go to play character. Here, take a closer look. I'm sorry, not play character. I'm a little bit tired. But to the consumable base. So when consume, take a closer look one more time. Sets when we have the input from our play character. It has the reference to the consumable we need to remove. Then we actually are corresponding to the inventory component and trigger remove from inventory event. Make sure that all events that you are actually firing are messages. You don't use call interface functions because we are actually corresponding or communicating between different classes. Now, inventory component. Here you can see the implementation of remove from inventory event, and as you can see we have the reference set to our local variable last consumable. Then from it we get our current quantity and decrease it by 1. Next we need to check the condition whether our current quantity of the proper consumable equals 0. If it's so, we need to send 3 types of messages. Set active consumable with the null reference, update by menu with the null reference, and update consumable widget with null reference. So when we have null reference and set active consumable, our play character, as you can see, will have active consumable null. And when we try to trigger use consumable, it just won't fire. So consume event won't trigger. And update by menu and update consumable widget. If we have consumable null here, our by menu will receive in by menu data null. It won't be valid, so it will remove the last active consumable and remove its position, so our by menu won't display our destroyed consumable. Also the same for update consumable widget for our slot. For this one, if we have here null, we just hide our widget. And whether this condition is false and we have some quantity, we just need to do the same but provide last consumable, so the information will be updated. And the last that is left is to show you how to create actually these consumable items. So go back to our folder interaction, which is called interaction system, then to the folder called consumables. Here, as you can see, I have three kind of consumables. As I said earlier, you can create them by right-clicking, selecting blueprint class, then search for consumable base, and it will be the child. It will inherit all the logic. So let's go with food consumable, and as you can see, that's actually the whole consumable of our food. Here I have the debug print, which actually tells I have some food, and as you can see, in class defaults, we need to provide the proper raw name, so the database will send the proper data to our consumable. And you can go with simulation physics, whether you like your consumable to be actually physical. You should remove this debug print, and after that you can put your custom logic, so your consumable will have its own unique logic. Also make sure to add event consume here and co-event parent consume in all of your consumable child. So when event consume fires from the player's input, it actually will fire the parent implementation first, and then your custom logic. You need this because our parent consumable class here has the event which is called remove from the inventory. So you won't need to do this kind of logic in any of your child. The same for water, event consume, co-parent consume, your custom logic. Make sure class defaults set proper raw name. When you create a child, there won't be these nodes, so you need to actually search for them in the context menu. Event consume. Now I'll go through all key elements, show you everything one more time slowly, so you won't miss any blueprint logic implementation and your consumable system will work as it intended to work. So, inventory component, add to inventory, check condition, add new one or continue with the one we have. Then check whether we have the same class with our last consumable and our active consumable, and actually update the amount of elements, remove from inventory, remove, decrease, variables. Next, consumable base class, construction script, event graph, main body, full stack, interacting with the same class object, attaching the first element to our player character, consuming, raw data table, consumable, static mesh, and player character, set active element, consume, consumable, event begin play, create consumable widget, event destroyed consumable widget, last interactable, active consumable. Next, player controller, update consumable widget, then create and destroy consumable widget, next, HUD pie menu, event destruct, remove child widget, then select proper element and update character and player controller. Here spawn child widget and update by menu slot. Now the functions. Spawn child widget, next update by menu slot, next select proper consumable, and update by menu data. And the last one, HUD consumable. Update consumable data and event graph. So, if you follow this tutorial step by step, slowly, maybe with pausing, you can actually achieve this kind of consumable system with some sorts of inventory. And that's all for this tutorial. So leave your comments and subscribe if you like my videos. See you soon!